Attention heat map. Multi-head attention is a powerful concept that enhances the attention mechanism in natural language processing by allowing the model to focus on different aspects of a sentence simultaneously, creating comprehensive representations that capture different perspectives. The attention heat map provides an intuitive graphical visualization of these attention scores, allowing users to see which words receive the most emphasis across different attention heads. In masked language model (MLM) tasks within BERT, these concepts work together to accurately predict missing words based on surrounding context, revealing how the model understands relationships and meaning in text. This collaboration ensures that BERT excels at understanding language nuances, helping researchers refine training strategies for improved language comprehension. With this tool, you will learn how the multi-head attention mechanism works and how it helps in modeling a natural language. Let's explore this tool. Consider this simple example of modeling and understanding of a small number of sentences. Here we have a collection of 6 sentence pairs or sequences, which will be used in training a masked language model or MLM. In MLM, certain words in a text sequence are intentionally hidden or masked, and the model's goal is to predict these missing words based on the surrounding context. This training approach enables the model to understand the meaning and relationships between words, leading to better comprehension of the language. We use sentence pairs because they enable the model in predicting the sentence flow and sequence. In the context of MLM training, the text provided serves as an excellent input dataset. Here, each sentence contains common words and logical sentence structures that the model can use to understand language patterns. For instance, phrases like "the cat chased the mouse" and "the sun rises in the east" establish relationships and context that the model can learn to predict missing words. Here, in this section, masked input text, the sentences are shown with specific words replaced by the special mask token. The goal is for the model to predict these masked words like cat and chase based on the context provided by the surrounding words in each sentence. This training approach allows the model to learn how words relate to each other and to accurately infer missing words. In MLM training, the CLS token marks the start of an input sequence and is used for input classification tasks. The SEP token separates distinct segments or sentences within the input, and the pad or padding token fills sequences to ensure consistent lengths across the batch, allowing the model to handle varying sequence sizes efficiently. It takes the length of the longest sentence and adds padding tokens to the other sentences to match the length of that longest sentence. Please note that the attention score calculation and heat map shown in this tool is taken from the last attention layer of a simple BERT model trained on the given input sentences. It visualizes the final attention distributions that the model uses to predict the masked words, reflecting the learned context and relationships from all the preceding layers. A more detailed end-to-end demonstration of the BERT model is shown in another tool on this portal called BERT Explorer. The attention score calculation section visually represents how input data, here sample 0, is processed to compute attention scores within the multi-head attention mechanism. Here we have input X. This green box on the left shows the input sequence as a matrix of numerical embeddings or word embeddings of all 14 words in this sentence with the embedding dimension of 7. Please note that not all words and not all embeddings are shown to avoid overwhelming the diagram. Only a subset of each tensor or matrix is displayed on the diagram. We have another tool on this portal, as mentioned before, BERT Explorer, which shows all the matrix values. Weight matrices. The matrices in black transform the input embedding matrix X into queries, Q, keys, K, and values, V, entities. These weights in these matrices are adjusted during the training process to accurately predict the masked words in the input sequences. In this diagram, WQ transforms X into Q, WK transforms X into K, and finally WV transforms X into V. Of course, Q, K, and V being queries, keys, and values. The query, key, and value matrices. The input matrix X is multiplied by the weight matrices WQ, WK, and WV to produce Q, K, and V matrices. Q, K, and V have dimensions 14 by 20, where 20 is derived from the transformation process, that is, the product of the input dimension and the weight matrix dimension. Splitting Q, K, and V into multiple heads. Q, K, and V matrices are split into multiple heads to capture different aspects of the input data. In this example, Q, K, and V are split into 5 heads: Q0 to Q4, K0 to K4, and V0 to V4. We left off showing the 5 heads for the values just for simplicity purposes. Each head has the dimensions of 14 by 4, where 4 represents the dimensionality of the head. Let's do attention calculation. Each attention head calculates attention scores by taking the dot product between the queries and the keys and normalizes using softmax. That's all represented in this formula. The attention heat map section visually demonstrates how multi-head attention functions within the MLM model by displaying attention scores in a grid format. Here's an explanation of how this part of the tool works. Input sample. You can choose different input text samples, sample 0, 1, 2, 3, and I'll come back to sample 0. And this helps us see how the attention scores are distributed across various words for that specific input. Epochs and iterations. You can navigate between epochs by hitting this next or going back, and that helps us observe changes in the attention patterns over the training process. Heads. The attention scores are calculated across multiple attention heads: 0, 1, 2, 3, 4, 4, and we can come back to 3. Each head captures a distinct pattern of attention, giving a unique perspective on which words receive focus. Heat map visualization. The rows represent words or tokens in the input sequence, while columns show the words that they attend to in the input sequence. Each grid cell displays the normalized attention score from 0 to 1, with higher scores highlighted in brighter colors. The darker cells imply lesser attention focus. For instance, at the epoch 2500 of 5000, and for sample 0 and head 3, we can see that the sample is the cat chased the mouse. It was a fast chase. There's a strong attention weight between cat and chased. Also, the word fast attends heavily to chased. This head seems to be capturing the subject-verb-adverb relationships in sentences. Combining heads. This is not shown in the picture, but the outputs from each head are concatenated to form a single matrix, which is then used to compute the final output of the attention mechanism. This combined matrix retains information from all heads, capturing different relationships within the data. This mechanism of computing attention scores and generating a new set of context-aware word embeddings is a part of a well-known component called the encoder. And there are many encoders in typical NLP models. Each encoder consists of a multi-head attention mechanism followed by a feed-forward neural network, allowing the model to build complex representations of the input data through successive layers. This deep stacking of encoders enables the model to capture intricate patterns and relationships in the data, leading to more accurate predictions of masked words. The output from the final encoder layer, which contains rich context-aware representations of the input tokens, is fed into a prediction layer. This prediction layer uses these representations to accurately predict the masked words by considering the learned context and relationships from all the preceding encoders. The prediction layer between encoders and the output is not shown in this tool for simplicity. A more detailed end-to-end demonstration of the BERT model is shown in the BERT Explorer portal. Output section. The output section of the tool displays the sentence after the model predicts the masked words as it's being trained. So I'll go to sample 0 and I'll start at epoch 1, and we can see that initially the masked words in the input sentence are replaced with the masked tokens. But as I go through the epochs and I iterate, we can see that the model then predicts the most likely words to replace these masked tokens, and it's reconstructing the sentence. So it went from mask to shine to mouse to cat, which ends up being the final prediction for the masked tokens. This section allows users to compare the predicted words as the model is being trained. In the context of NLP and BERT, when masked words are predicted during training, the attention mechanism tries to predict the most likely replacements by considering the context provided by surrounding words. The predicted words are compared to the actual ones, and the error is calculated using a loss function. During backward propagation, the attention scores and other parameters are adjusted and used to update the model to improve the prediction accuracy. This iterative process of prediction, error calculation, and parameter adjustment fine-tunes the attention scores and model parameters. I hope using this tool, you will be able to visualize and understand the inner workings of the multi-head attention mechanism in a simple NLP model like BERT. Please feel free to play with the tool by choosing various input sample sequences, epochs, and attention heads.